Welcome back to the deep dive. Um, Usually when we talk about data science or, AI and precision architecture, we're looking at Silicon Valley startups.
Right, or like high-frequency trading firms.
Exactly. But today, we're going to a place that, frankly, I did not expect to find on our radar. We are heading to Lake City, Michigan.
Yeah, not exactly the tech capital of the world.
It really is not.
Yeah.
And we aren't visiting a server farm today. We are walking into a laundromat, specifically one called Super Clean Laundry.
Though, if you read through the documents we have today, the blueprints, the operational scripts, this place is never just referred to as a laundromat.
Right. It's called the Living Lab.
Yes.
And the owner, Nicholas J. Gomez, he doesn't call himself a laundromat owner either. He is the precision laundry architect.
I know, it sounds a little grand, right, for someone dealing with quarters and lint filters. But once you get into the core vocabulary document provided in our sources, you realize that title is actually very literal.
How so?
He isn't just running a small business. He is architecting a highly precise system.
I mean, I want to push back on that immediately, though, because architect feels like a buzzword. Is this just clever branding, or is there actual substance here?
There's real substance.
Because looking at the mission statement, the goal seems almost impossible for a rural small business. I mean, he's aiming for a strict 10-hour work week and total financial freedom using AI.
It sounds totally impossible if you look at it through the lens of how laundromats are normally run. And that right there is the central conflict in these sources. It is a battle between two completely different philosophies. On one side, you have what Gomez calls manual grit.
Which is clearly the villain of this story.
It absolutely is. Manual grit is the default state for most operators. It's the owner who is constantly reactive. Like, a belt breaks on a washer, you drive to the hardware store to get a new one. A toilet clogs, you plunge it.
You are trading your physical labor and your stress for money.
Exactly. You feel productive because you are sweating and moving fast, but you aren't actually building anything scalable. You are just maintaining chaos.
I think you listening right now, you can probably relate to that. And not just in the laundry business, it's that firefighter mentality.
Huh.
You feel like the hero because you put out the fire, but you never stop to ask why the fire started in the first place.
Right, and the alternative presented in the source material is precision laundry architecture. This is a total mindset shift. It's moving from being what the linguistic guardrails document explicitly warns against being a hobbyist to becoming an infrastructure builder.
So the goal isn't to fix the broken machine.
No. The goal is to build a system that predicts when the machine will break and fixes it before the customer ever even notices a problem.
And so this living lab up in Lake City, that is where he tests these predictive systems.
That's the validation ground. Because theory is nice, right? But if an operational protocol fails on a busy Sunday afternoon with a store full of angry customers, it gets scrapped. If it works, it becomes part of the official blueprint.
Let's get into the actual scenarios tested in the lab then, because I want to start with something that seems incredibly basic, but it takes up a massive portion of the operational manual: sanitation.
This is actually a perfect place to start. It perfectly illustrates the difference between simply cleaning and actually engineering. In that old manual grit model, sanitation is just, well, the floor looks dirty, go grab a mop.
And in the precision model,
In the lab, they identified a specific scenario related to customer churn. The data showed that if a facility feels dirty, customers leave and they never come back. But dirty is subjective. So they implemented what they call clinical grade sanitation.
okay, I'm looking at the system implementation sheet here. It lists color-coded hardware. It lists EPA-registered chemical concentrates. And look, I have to play devil's advocate again here.
Go for it.
We are talking about a laundromat in rural Michigan. The margins on a wash are literally pennies. Does it really make financial sense to buy hospital-grade cleaning supplies and fancy mops? I mean, that sounds like a great way to just burn cash.
And that right there is classic manual grit thinking. You are focusing on the sticker price of the mop. The architect doesn't look at that. The architect looks at efficiency per cycle, or EPC. Let's run the numbers based on the lab's findings.
Okay, walk me through the math on a mop.
Let's say you buy a cheap cotton mop head for $5. It basically just pushes dirty water around. It leaves the floor soaking wet for 20 minutes, and you have to replace it every 2 weeks because it gets gross. Plus, it takes your employee 30 minutes to do the floor because they have to go over it twice just to get the streaks out.
Standard operating procedure for most small businesses, honestly.
Right. Now, the lab switches to a 2-bucket system with an industrial microfiber flat mop. The setup costs $100 up front, But because the system physically separates the dirty water from the clean chemical concentrate, the employee never mops with sludge.
Makes sense.
The floor dries in 2 minutes instead of 20, and the actual labor time drops from 30 minutes to 20 minutes.
Saving 10 minutes a day. That doesn't exactly sound like an operational revolution.
It is when you scale it. 10 minutes a day is roughly 60 hours of paid labor a year. If you are paying $15 or $18 an hour, you just saved nearly $1,000 in labor. Plus, that industrial gear lasts 6 months instead of 2 weeks.
Wow, okay.
You spend $100 up front to save $1,000 on the back end. That is precision architecture. You are investing in infrastructure to reduce operational friction.
So the higher upfront cost of the industrial tool is justified completely by the reduction in labor latency.
Precisely. You are using a data lens to filter out the noise of this bucket is expensive to find the real ROI of this system buys me time.
There's one detail in this sanitation blueprint that I found completely fascinating, and it has nothing to do with mops or chemicals. It's about plumbing, the P-trap.
Ah, yes. The P-trap hydration levels.
For those of you who don't know plumbing, a P-trap is that U-shaped pipe under a sink or under a floor drain. It holds a little bit of water to block sewer gas from coming up into the room.
Correct. And in a commercial laundromat, you have floor drains everywhere to catch washer overflow. In the manual grip model, you basically just ignore them until there's a flood. But the lab discovered a critical vulnerability here. If those drains dry out,
sewer gas seeps in.
Exactly. And the place smells like a sewer. And this is where we have to talk about sensory architecture. Because this isn't just about a bad smell, it's about evolutionary biology.
Oh, this part was wild.
Olfactory memory smell is the most direct link to the lizard brain. If a customer walks into your business and smells sewer gas, even faintly, their brain instantly triggers a deep disgust response.
Even if the floor is sparkling clean from that $100 mop.
It does not matter. The visual data says clean, but the olfactory data says danger or filth. The customer will subconsciously label the entire business as dirty and unsafe. Their internal cleanliness score drops to 0 immediately.
So how did the architects solve this in the lab?
They didn't just buy a bunch of cheap air fresheners. They engineered a system. They implemented a weekly drain maintenance SOP, a standard operating procedure. It's a scheduled manual hydration of every single P-trap in the facility to ensure that water seal never, ever breaks.
And the audit result?
The lab achieved a 100% elimination of sewer gas backups. 0 cost to execute, just a minor process change, but it completely removed a massive, invisible barrier to customer retention.
It really is amazing how much of this architecture is entirely invisible. I mean, it's not about a flashy new neon sign out front, it's about maintaining water in a pipe. Which leads us perfectly to the next segment of a source material, magic variables.
This is easily one of my favorite concepts from the deep dive today.
So a magic variable is defined as a small, high-impact adjustment, like tweaking water temps or cycle times, that drastically affects profitability or customer perception. And the specific one highlighted in the documents is the closing pose.
The closing pose.
Which, despite what the name implies, is not a yoga move. It refers to the bathroom. Specifically, the simple act of tucking the toilet paper into a neat triangle and lowering the seat before the attendant leaves the room.
I know it sounds trivial. It almost sounds silly when you first read it.
It really does. I mean, we were just talking about APC and efficient labor. Isn't an employee standing there folding toilet paper a literal waste of time?
If you view it strictly as a cleaning task, yes. But if you view it through the lens of game theory, specifically the concept of costly signaling it is brilliant.
Break that down for us. What exactly is the signal being sent here?
When a customer walks into that restroom and sees that crisp triangle fold on the toilet paper, they aren't thinking, oh, someone folded this. Their subconscious is instantly registering a very specific signal. This environment is under strict professional control.
It implies that if the owner cares enough to mandate folding the paper, they definitely care enough to maintain the complex washing machines.
Exactly. It creates a psychological halo effect. The precision in the bathroom implies precision in the machinery. It is a zero-cost infrastructure variable that signals a high-precision operation to anyone who sees it.
And the architect actually puts a hard dollar value on this psychological signal.
They do. The water cooler brief projects a positive 4% shift in customer lifetime value, or CLV.
A 4% bump just from the vibe of the bathroom.
From the trust. Think about it. In a rural market, or really any market, customers have baseline anxiety. Will this machine rip my expensive clothes? Is this place safe at night? Is it clean? The closing pose immediately reduces that anxiety. It tells them, we are watching the details. That creates hygiene-driven loyalty. And in a recurring revenue model like a laundromat, retention is everything.
Wow. Okay, so we've covered the physical layer, the mops and the P-traps, and we've covered the psychological layer with the costly signals and the folds. But the core promise of the mission we discussed up front was a strict 10-hour work week. You cannot fold toilet paper yourself if you're only on site for 10 hours a week.
No, you absolutely cannot. You need a robust digital architecture to handle the daily operational load. And this is where the AI integration comes in.
The tech stack described in the blueprints is fascinating because it's surprisingly lean. It isn't some bloated million-dollar enterprise software suite. It starts with an AI receptionist called Bella, or sometimes referred to as Hey Rosie.
This AI is the first line of defense because in the manual grit world, if a commercial client, say a local spa or a restaurant, calls to ask about bulk pricing, and the owner is busy fixing a broken dryer, that call goes straight to voicemail, and that lead is instantly lost.
And in the precision model,
Bella answers the phone 24/7. She can handle the complex inquiry. She can quote accurate prices based on the parameters she's been trained on, and she can even schedule a pickup.
that's incredible.
The owner doesn't even know the call happened until they are reviewing the revenue report at the end of the week.
So the AI essentially acts as a highly efficient filter.
Exactly. It filters out the daily operational noise, so the owner is only forced to deal with high-level strategic decisions. But I'd argue the most impressive part of this entire digital architecture is how they use data analysis to locate unproductive consumption.
Yes, unproductive consumption. That is a massive key term in the documents. What does that actually look like in practice for an operator?
Think of it this way. Imagine you have a hole in your pocket. You go to work, you earn some money, you put it in your pocket. But by the time you walk home, a percentage of it is just gone. You did the hard work, but you lost the value. That is unproductive consumption.
In a commercial laundromat, we are talking about utilities.
Right. Water, gas, electric, these are your absolute biggest variable costs. The manual grit owner simply looks at the monthly water bill, sees it's $2,000, and sighs. They just think, well, business must have been good this month.
But the architect doesn't just look at the bill. They use a cost filter.
Yes. They take the raw utility data, exactly how much water flowed through the city meter, and they cross-reference that with the point-of-sale data from the machine turns. They use a POS system called Sense or Hub.
Okay, so if the POS software says we sold 500 paid wash cycles this week, and we know exactly that one wash takes 20 gallons of water.
Then you know for a fact you should have used exactly 10,000 gallons of water.
Right.
But if the utility data shows you actually consumed 12,000 gallons, you suddenly have a 2,000-gallon delta. That delta is your unproductive consumption.
It's invisible waste.
Exactly. It could be a toilet running in the back room that nobody noticed. It could be an employee using the massive 80-pound washer to clean their own rugs for free after hours. Or it could be a slow, catastrophic leak in the foundation. The AI-driven cost filter highlights this discrepancy immediately.
And without that specific AI analysis bridging the two data sets, you would just blindly pay the utility bill and never even know you had a leak.
You would just bleed profit forever. The AI allows the owner to minimize what they call system latency, which is the amount of time between a problem actually starting and you discovering and fixing it.
You know, that specific concept of system latency really stuck with me reading through this. In the manual grit world, your latency is incredibly high. You find out a toilet has been running only when you get an astronomical water bill a month later. In precision architecture, the digital system flags the anomaly almost instantly.
And that speed, that lack of latency, is exactly what makes the 10-hour workweek possible. You aren't spending your precious time constantly hunting for hidden problems.
The system hunts for you.
Right. The system hunts for the problems, uses AI to analyze them, and serves them to you on a silver platter. You log in, look at the dashboard, and just make the executive decision. Call the plumber. Done. Back to your life.
It's so interesting because we started this conversation talking about a laundromat in rural Michigan,
Right.
but this is really a masterclass in high-level systems thinking.
Absolutely. The Living Lab is just using commercial laundry as the physical medium. But the actual art here is the architecture itself. You could easily apply this exact same framework to a coffee shop, a consulting firm, or even just your own personal household management.
So let's wrap this up with some actionable advice for you listening right now. Maybe you don't own a laundromat, but you definitely have areas of manual grit in your own life or business.
I would say start by identifying your own unproductive consumption. Where exactly are you leaking your time or your money without getting any measurable value back? Do you have the digital equivalent of a running toilet in your daily workflow?
And on the flip side of that, you need to look for your magic variables. What is the closing pose of your specific profession? What is the one small zero-cost signal you can send to your boss, your clients, or even your family that clearly says, I have this environment under strict control?
And please don't underestimate the power of the P-trap. The sensory baseline details matter immensely. If your professional emails are full of typos, that is a sewer smell.
Oh, that's good.
If your Zoom background is chaotic and messy during a client call, that is a sewer smell. You have to fix the invisible leaks that are subconsciously hurting your reputation before you try to scale.
I love that framing. Typos are the sewer gas of the corporate world.
It's entirely true. It triggers that exact same lack of precision response in the client's brain.
Well, if you want to see the actual blueprints we discussed today, or if you want to look at the hard math on the mops, or even see the specific AI prompts Nicholas uses to program Bella, the AI receptionist, they're all available for you. You can check out all of this in the Load Down newsletter.
And the central hub for all of these resources is aiforlaundromats.org. There is an entire community of architects over there building these automated systems together.
Before we sign off today, I want to leave you with a final provocative thought to mull over on your own. It builds on that idea of system latency we just talked about. We defined it as the delay between a problem occurring and your system detecting it. But think about your own life right now. How long does it typically take you to realize something is fundamentally wrong in your routine? Is it a day? A month? A year?
That's a scary thought.
The ultimate goal of the architect is to shrink that gap to zero. How short can you make that gap using the AI tools available to you today? Stop running around putting out fires. Start building smoke detectors.
Perfectly said.
That is the mission. Thank you for joining us in the lab today. This has been the audio lab for the Precision Laundry Architect Project.